0 done. Unmute. Okay, so let's start. Welcome guys, once more welcome to this webcast. Today we are looking into SolidWorks plastic standard and how it can help plastic part designers, what are its capabilities and what is the value that it brings in. So I believe most of you may be aware, we had a chain of webinars wherein we have covered certain things in simulation, certain things in flow, and today it is on plastics. So if you have missed any one of them and if you need the recording, please feel free to contact us. We can share the recording with you. Myself, I am Kapil Gaitonde. I am the technical manager for simulation products. I am based in Singapore and I am covering all the South Asian countries and Australia, New Zealand for these simulation products. So let's move on into today's topic, which is plastics. And before we get into the product, obviously we want to understand the value that it brings and where exactly it can make a difference. So if we see this simple image on the screen, I would say this is more of a historical plastics development process wherein we are looking at the influence of it on manufacturability and quality. So typically in the previous process wherein we moved all the way from part designing to product launch, at the initial phases the manufacturability and quality comparatively can have a higher influence if we can do the part design changes quite early in the process. However, as we move ahead in the process and the responsibility for meeting the launch requirements increases, any change would be very expensive, no doubt on that. And unfortunately, we had a kind of process that we follow in this way. At the first two stages, obviously the responsibility is with the mold designer or rather the part designer. He does have enough control, but may not be simulating and leaves most of the things to the mold designer or the mold manufacturer or the part manufacturer. And unfortunately it can lead to a comparatively higher cost in production. So if I see it in a different perspective, it could be something like this, where we have the part designers, we have the mold designers. So typically we go through this cycle wherein we are the part designer designs is there, on the mold designer is going to create the mold. The mold is built, production happens. Unfortunately, for any reason, if we detect a defect here, then this cycle may have to be repeated, and one can imagine the cost effects of that. Other way around, it could be a little bit different, wherein I do the part designing, I do the mold designing, and before I actually manufacture the mold, I might be doing some sort of or some kind of in-depth simulation. That is, I am going to test the mold. Yes, this can also help. This can help to a certain extent, but obviously we are already at a later stage in the design, as you saw in the first slide, and we have control only on the mold. Part is already decided and frozen. We may not be able to do any changes. So we might be required to imbibe some intricate things inside the mold, which can be expensive, and in one way or the other, this can be seen as hidden cost as well, and that can lead to comparatively a higher cost. As well, there can be many other implications in terms of repetitive work or changes which can unnecessarily delay the design cycle. And finally, I would say what would be the preferred way or the way that we are proposing today or discussing more of is this one, wherein I design the part and I simulate. So here the simulation that I am talking is more in terms of plastic injection, simulating the plastic injection process. I do many finer things over there so that I know this part can be manufactured in a certain way using a certain material with a certain thickness. So those can be frozen at the part design stage itself, and thereon I give the part to the mold. So we are already at an advanced stage, no much to and fro between the part designer and the mold designer. Once these things are done, I release the part to production, and when the mold designer as well has done enough simulation, he is sure that it is going to work. So obviously this can reduce or other way around seen in the initial stages where we are more where we have more control and the cost of change can be low. We can do enough changes and thereon release the part confidently. So obviously this looks like a more strong process which can deliver better parts at a faster rate, and of course which can be manufactured as per your requirements. So we have very well understood, and this slide again re-emphasizes this fact. Typically at the part design phase, the cost of change is comparatively low, and the impact of change can be higher. So we can spend most of the time down here, and the simulation part or the plastic injection part is what we are going to understand, or the part design simulation is what we are going to understand today, how we do it in the software. Plastics, on a quick note, what it can do, it can, of course, the primary topic for today, it can avoid manufacturing defects. So we will see which are those and how it can avoid. Eliminate costly mold rework. So this may not be covered today, but it does have capability towards simulating multiple cavities, multi-family molds. You can optimize runners, gates. You can also simulate cooling and warpage. So those things could be relevant for mold designing. Even those can be done. You can of course improve the part quality and decrease time to market. So ultimately our aim is to release these parts in a faster way with a better quality. And if you see it in terms of applications, most of the parts, or almost more than 80% of the parts, are manufactured using plastic injection. I mean in the plastic parts, different kind of plastic parts. Of course, injection molding is a complex process, and yet we are aware of few important parameters like temperature, pressure, material, and tooling variables which we can play and get the right part. Injection molds range in cost from all the way to $10,000 to $1 million. So if you see it in one way, even if I can save the rework or change of one mold, then we are getting the ROI of this particular software. So this is the way it works. SolidWorks Plastics, a few more important capabilities from a software perspective. It has an extensive database of plastic materials. So typically most of them are coming from commercially available plastics, so you need not search for them. They are all available in the software. Comprehensive range of analysis capabilities, that's what we'll have a look today. Guided analysis setup, again when I show you in the software, you'll understand how easy it is easy to use, and you can do it. Other elements of differentiation, it is well integrated into SolidWorks CAD. So we are not talking about multiple softwares. The plastic simulation will be done within the CAD module. It is quite fast and easy to use. No import or export, no data loss. So these are a few from a software perspective. If I go back and if I say a few more words on plastic standard, that is the module that we are going to look at today and its capabilities. So few basic things that it does, it can tell you will the part fill, that is whether it can be filled or there can be short shots, where would be the weld lines, will there be any air traps. You can simulate these basic molding things in this particular module. Of course, as a part designer, you might want to optimize your part, so you can do that based on the filling requirements. You can also determine the best gate locations. Two other modules, that is Plastics Professional and Plastics Premium. I'm not going through them today, but we have it, and we do have a webcast in due course of time wherein I'll cover more of the requirements and what we can do for mold designers. So Plastics Premium is one page. So let's have a look at SolidWorks Plastics module. So here it is. Plastics. So here it comes. So as I said, we have these three different modules, and today our concentration would be on plastic standard. If I quickly go through the basic capabilities, one of them could be simple filling. So typically a plastic part is there. plastic is injected from a certain location. I want to see in how much time it fills, or it could also be that whether it will fill or it fails to fill. Okay, so it could be something called a shot. We can understand that. Thereon we can understand air traps. So typically when a plastic fills into a part, it can trap certain amount of air at different locations, and this trapped air can cause bad surfaces which are not aesthetically nice. So obviously I want to avoid it, or I want to relocate them to a location where it is fine to have such defects. Third one could be sink marks. I also want to play with the part design such that certain areas where comparatively higher thickness is there, there is a possibility of sink marks. I will avoid them by using appropriate thickness values of the parts. I can change a few different parameters, and this can be seen as more of an optimization as well, so that I give the appropriate strength to the part. In the meanwhile, I want to avoid sink marks. Multiple gates or even single gate, I can understand how it feels. I can have, obviously using multiple gates, I can suggest the mold designer on the gate location and how it can help in getting a better part which fills appropriately and does not have these defects. Finally, weld line, again probably more from a strength perspective. Typically when such a plastic flow comes and joins at certain locations, you can see a kind of line, or other way around, the comparatively the strength at these locations should be lower. So I want to design the part such that the plastic or these weld lines are at a location where there is minimal load, or there is lesser amount of load in those directions. So that's what it is. So this is all about plastic standard. We'll have a look at it in the software as well, but this is what its capability is. A few other things in terms of simulation professional, if you can quickly see on the screen, we can simulate multiple cavity. It has a runner balancing option. We can do shrinkage. We can simulate insert over molding. It could be gas injection, simulate gas injection molding. We can simulate co-injection. We have the options to look at fiber analysis and birefringence. And finally, in terms of premium, we can simulate warpage and design or understand the cooling lines, how you want to go about it. So let's move into the software. Please let me get into the software. Here it is. So I have a part, as you can see down here in the screen. Okay, a simple part. I'm going to show you the steps through which you can follow in plastics to create a particular setup. Okay, once you have plastics installed and activated, you should be able to see this particular tree, or it could be also be activated through the SolidWorks add-in. Ensure you activated it. I go into SolidWorks plastics, and the top left corner you will see something called as getting started wizard. Okay, I select that, and then I flow through the different options over here. Let me pin this particular wizard, and if I go to options, you can see I can decide the unit in which I am looking at this part. Ensure that this checkbox of integrate with SolidWorks is activated. So SolidWorks talks well with this, especially on the configuration front. It will match. Let me move to the next step. So here you can see we have two different options. One of them is more towards shell mesh, and second one is solid mesh. Okay, so in shell mesh, typically we are looking at parts which are comparatively uniform in thickness. So if I scroll through this part, you can see here most of the walls, or almost all the walls, are of same thickness. We do have the thickness analysis option in SolidWorks plastics which can be used. However, you can use, as a designer, it is your own part, you know the thickness variation. As well, using shell mesh can be a faster analysis, so you can do that. I select shell mesh, okay, and I select the next option down here on the left side. I have already meshed this part, so it is asking if you want to remesh the part. I say yes. Thereon you can see here, now in this case there is only one body which is treated as cavity. If you want, you can decide certain bodies to be treated as cavity, the others could be treated as inserts, or you might also have cooling lines, the pipes necessary for cooling lines, those can be filtered over here. So in this case only cavity is there. I select it, and thereon in the next dialog box I have the option to give the mesh size. I can play with the refinement levels if at all you want to do. I keep it all default and select the mesh option. So here it is, it has created the mesh. You can see the way it looks. It is a shell mesh, quite fast, right? This is done. Let me just go to the next boxes. Nothing much to be done here. I just accept it. Okay. So meshing is done. I move to the next option in the wizard. The next one, as you see here, it has taken a default material, typically melt, and it is showing the important material properties like melt temperature, mold temperature, and the material used. If you want to change, you can select the change material option here. So this is the database that I was talking about, an exhaustive database. We have different options. One, it could be the default database, or you can have your own custom user defined database. If I go to default database, you can sort the materials based on family or by company. Okay, so there are different companies who have given us their database of materials. They have been all listed here. Or it could be by family, kind of, that is more of a kind of plastic, so you can decide which one you want, and you can shortlist and use it from there. At the moment we are using a custom material which has been used in this setup. You can just scroll through the different materials if at all you are interested, and this is how it is. Let me go back for that, and I keep it and I go to the next one. Obviously the next important thing will be the filling location and the injection pressure. Obviously the injection pressure limit is based on the machine that is used for manufacturing. So as a part designer, you may be knowing or you may not be knowing. Of course we do have a huge set of machines down here through which you can actually see the capabilities of different machines. You can understand the different machines, their capabilities, their clamping, maximum clamping forces, maximum injection pressures that they can inject. So if you are aware from the customer or your manufacturer, or if you yourself have the machine, you can check from here and you can decide which machine to be used or is being used, and you can decide the maximum injection pressure that this part, or maximum injection pressure that the machine can exert on this part. Okay. Mold temperatures, typically plastic material property, the mold, the temperature at which the mold will be maintained. Melt temperature is the plastic material property, so it is taken from the material database. If not, you can also overrule it from here. Let me move to the next step, which is more on the injection location. Let me click this add injection location. We have a few different options down here. So if you see here, and the rightmost option, which is or the second rightmost option, is like add injection locations automatically. This will permit you to select the number of injection points, and we can and the software will tell us, if I select 2, which could be the appropriate locations from which you can fill this part. So at the moment it is showing one down here, the other is on the other side. Obviously it is doing it based on the mass, the center of gravity, and if this logic is not good enough for you, obviously it makes sense to add your own injection locations, right? Let me select a certain location down here. Probably I'll go to one extreme so that I can see the filling down of the part. Okay, I select somewhere over there, and I can give the diameter of the injection location, and I just press the button here, accept it. So this is the way we are creating the injection location. This is location and the diameter, injection pressures are given, and this is the way it proceeds. So finally, the last step would be running the simulation. I can click run simulation. It starts off. You can see here. The best part is while this is solving, we can actually see the progress on the monitor. So at the moment it is at meshing, processing the mesh rather. Let it go ahead, and with time we'll be able to see the results as well on the screen. Let me zoom in down here. This will take a few minutes while it so at the moment you can see it is processing the mesh. %, and okay, so this will take a minute or two to solve. Now it is processing the model. While this happens, I will scroll through the chat window and questions panel to check if any questions are there which I can handle. However, you as well can ask me questions. No. Okay, one of the questions is can you please show the difference in the versions again? So I will scroll through the that particular slide and show you the difference. Apologize guys, I think initially a few of you faced audio problems, but guess it is all okay now. However, in any case, this is a recorded session. We can always share it with you. Feel free to ping us once this is done and we can give you the recording. Okay. Now, few different things. As you can see, while it is solving, in parallel to this as well, you can see the results. So the results panel is already active down here. You can see, first of all, fill time. So it is showing a max fill time of around 0.19 seconds to fill to an extent as shown on the screen. We can see also other results like pressure at the end of the fill. So this is the present maximum pressure, central temperature, average temperature. So all these parameters can be actually seen even while it is filling this particular part. So this is a very useful thing. You need, because typically a plastics analysis is a very time consuming analysis. It can take a lot of time to solve, but you can actually visualize the results even when it is solving. Okay, so this is a good part of it where you can do it. As well, of course, you can minimize this thing and continue with your SolidWorks CAD model. This is not disabling your SolidWorks CAD software. That can happen. Okay, let me get back to the other question, which was more on having a look at the plastics capabilities again. So if I go down here, so you can see the slide that gives the differentiation. So we have these three modules. One of them is called as standard, second is professional and premium. Standard is what we are seeing here at the moment, which will show you more of filling part of it. Let me use the highlighter. Yeah, so this is what we are seeing today. We'll see the filling analysis, which is already going. We'll also have a look at how it shows the air traps, sinks, etc. Thereon, professional is more towards packing. And apart from that, it can also help you simulate runner balancing, multiple cavities or family molds as well can be simulated. You can understand shrinkage. you can understand insert over molding. So if there are multiple inserts and plastic is filling, you can get a look at it. Cooling time, the total time required to cool the part. Gas injection, so in this particular process how gas can be injected and how it looks once you have that hole inside the part. Co-injection, you can inject multiple different plastics at different times or at different domains, and you can visualize it. And finally, fiber analysis and birefringence. So fiber analysis will help to visualize as well as know the density distribution of fiber, and birefringence can help in ensuring the parts, especially transparent parts, are manufactured without refraction. And in terms of premium, we can simulate warpage. So typically once the part comes out of the mold, there can be certain amount of warpage in the part that you can understand. Advanced cooling analysis in terms of designing the cooling lines inside the mold. You want to decide how the cooling line should be, what should be the appropriate design such that the part or the mold maintains a certain temperature. So you can understand that using this advanced cooling analysis. So this is what is the product capability, I would say. Let me scroll through the other questions. In terms of cost, I would not like to discuss here today because there are multiple countries and even I am not comfortable with the absolute values. Of course, we'll get our local executives in contact with you, and they should be able to help you with the right cost on this particular product. So there is another question which is more towards, is there a way to have SolidWorks show how a part should be molded, that is sliding course, etc. So in terms of simulation, as you saw, these are the few different things that the software can simulate. The output from this, now probably I understand the mold design, and thereon I can find out the forces required to hold this particular part, that is the clamping forces. I can also know the injection pressures, etc. So using these I can derive certain mold details. In terms of mold designing, in terms of creating the parting lines, etc., it can be also in the CAD part of it, and our CAD module does have some capabilities by which we can do that. Okay, let me go back to the software. Let me open the window. So we are at almost 70%, and this is where it is going. One more interesting fact, you can see a message down here. It is saying that the pressure has reached the maximum injection pressure. So obviously the injection location that I have taken may be incorrect. We can also have a bigger diameter for that particular injection area, or it could also be I want to change the location of injection, or I want to have multiple injection locations, or finally I may be required to have a different machine. But as a part designer, I can also play with the thickness. I can change the thickness of this particular part, and that can help us change or ensure that the part can be manufactured. So in this case, at this point of time, we have reached a stage wherein the pressure at the end of the fill, has reached the maximum limit of 100 megapascals, and obviously the part cannot be manufactured. So typically this is a classic example that can happen when a mold designer tries to design his mold, and he comes back to the part designer saying that no, this cannot be manufactured, and we are stuck. As a designer, I don't have any tool. I have to rely on the mold designer to tell me what to do, or whatever suggestions that he gives, you can try to implement. But as I told you, there are a few things which the mold designer can control, but there are a few other things which the part designer can as well control. So if I have to avoid this waste of time in terms of interaction with the mold designer and coming back, the best thing would be I simulate this particular scenario, while I am designing the part itself, I know the pressures are going quite high if the gate is at a certain location with a certain diameter. So what can I do? I can change the thickness. I can try different injection locations. I can try different plastic parts, come to a conclusion saying that okay, if I do these things, the part can be manufactured and this can be conveyed to the mold designer. So if I take this example with a few animations, you can see in terms of filling, it is not a complete fill, it is a short shot. It stops down there. It is taking around 0.75 seconds to do that. We are seeing the pressure at the end of the fill, and a few other different parameters can be visualized using this particular analysis. So obviously the next iteration would be I can try using a higher pressure machine down here to help this particular part fill, and ultimately that can be filled in that way. Okay, so this is one part of the analysis. I believe if you are trying the software, you can just follow these steps using the wizard and you should be ready to go. Okay, now let me close this. We saw the results. The other point which as a part designer which will be useful is something called as nominal thickness advisor, which I thought I'll highlight. So once you open this particular tool, it will help you understand the thickness variation across the part. So luckily in this part there is comparatively higher thickness variation, so the thickness is not constant. So ideally this part should be meshed with a solid mesh, but you can see here it is talking about something in the range of plus or minus 30%, which is comparatively huge. And typically for plastic parts it is suggested that they are of uniform thickness, especially if they are manufactured using injection molding. So you can use this nominal thickness, nominal wall thickness advisor to get a feel of the thickness at different locations and how you want to manipulate it. So, oops, sorry, it was actually processing. Now is the result. So most of it is around plus or minus 10%. Obviously less than that would be better. Yellow not much, but red there are certain locations. So if I take this red around here and the bossing at the bottom is comparatively having a higher thickness. So if given a chance, I might want to play with the thickness of this. I can add some stiffeners around to give the strength and do the changes to the part design. So this is what it is all about. In terms of part designers, one can understand and visualize these things and take a better decision in terms of designing the part such that it can be manufactured. You can get a good understanding of the different defects which we discussed, and that's what it is all about. So I think for today I would like to stop here. We had kept a time slot of 30 minutes. I overshot by 4 minutes. Yeah. So I will open the polling window now. So a few different things. The polling window is open. Please feel free to give your feedback in terms of if you would like to know more about this product, you want to talk to our executive, or if there are any questions which you want to discuss with them. It could also be any feedback on this particular session. Please feel free to give it. Secondly, any questions, any queries for me right now? I'm around here for a few more minutes. Please use the Q&A panel or the chat window to ask. I'm around here. Yeah. Okay, so the chat window does not show any questions. Let me check the other windows. There is a question on sliding course. I'm not sure if I can grasp this, but definitely it might need a discussion. Feel free to email me or ask me on any of these questions, and I'll try to get them.